My name is Lucian. Today I'm talking about the extensions framework and how that might allow us to orchestrate anything, or at least a lot of stuff. So as I've said, my name is Lucian. I'm a PMC and committer in the software, in the Apache CloudStack project. My background is sysadmin and data center operation. I'm passionate about free software, IT sovereignty, autonomy, and so on and so forth. And currently I'm a cloud architect with ShapeBlue, and that depicts me at work most days. So, why this? What happened? Why did we want these extensions? So what's the story? At some point, a couple of years back, we were wondering how to add certain extra stuff with CloudStack. For example, Hyper-V would have been a notable example. And somebody came with the idea, okay, let's make something that's very pluggable that we can just write scripts for, and that we can then use to deploy all sorts of stuff. So we came up with this extension framework, and the idea is for operators, users, and really anybody who knows even a little bit of scripting to be able to plug their favorite whatnot into CloudStack and manage it. If anybody has looked at the CloudStack code, especially at the hypervisor integration, it's a lot of code there. You need to really know what you're doing. This allows you to do quite a lot of stuff with not a lot of knowledge. Like somebody said, just with a little bit of vibe coding, you can go a long way. And I think this applies here as well. I'm not necessarily implying you should be doing vibe coding, but even a little bit of bash scripting can be enough. So with that in mind, so that's basically the story, and that's the feature. You write some scripts, and CloudStack will try to use them and deploy whatever stuff you want. Today I'm going to showcase, or I'm going to talk about how you can deploy instances. That's the only thing that we can do for now. This is, I think, a first incarnation or first version of this feature. But there are more coming because we want to also tackle other aspects of CloudStack, such as storage, networking, and so on. So what we're doing today is going to be how to integrate scripts to deploy external instances on external resources entirely until now foreign to CloudStack. And the result will be instances. So we're dealing with instances in CloudStack. What can we achieve practically? So as of the current version, 4.21, we can do the following. We can do Proxmox and Hyper-V. So these extensions come built in with CloudStack today. If you install CloudStack, you'll get support for some lost soul outside. Someone help him. All right. So today you can deploy instances on Proxmox and Hyper-V with MaaS coming. MaaS is a product from Canonical, and it allows you to deploy bare metal. And of course other bare metal frameworks, or really anything that you can script to convince them to do what you want to do. In addition to actually integrating this functionality of deploying instances elsewhere, be they virtual or indeed bare metal, there is also the ability to script custom actions that you can then perform on these resources. An example could be a snapshot, clone, or backup operations, or really anything you put your mind to it. And yeah, as I said, we are working on achieving the same for network and storage as well. So the idea is to integrate tools or workflows that are entirely external to CloudStack. in a way, when I was reading about this feature and listening to my colleagues talking about it, I was thinking, this sounds a lot like Jenkins, if you're familiar with Jenkins and CI/CD, because it can basically run anything if you really want it. And the whole idea is, as I said, you place an executable or a script or anything that can be run on the management server, and CloudStack will try to use it. You have the possibility of adding multiple such extensions in CloudStack. And as I said, it's the only type we support for now is orchestrator of instances, with others coming soon. The communication between the CloudStack management server and the extension, the script that you have developed, is JSON. It's a JSON payload that you can then read with your script or with your program, and then take the information that you require from there and then do the action that you want. And as I said, you can define custom actions. So in addition to creating them, you'll then have the ability to also perform custom actions on these VMs. And the extension can be anything. So I said it can be a script, it can be a binary, it can be in Rust, Go, whatever you feel like writing it in. The extension data, I'm not sure you can see the path from back there, probably not. So the two key paths to remember are on the CloudStack management server, user share CloudStack management extensions, and varlib CloudStack management extension. So that's where the data will be stored, JSON files, and so on. The workflow would look something like this. So you add an extension, then register the extension with a resource, add the supporting resources, then the user triggers an action, and then there is a communication happening. CloudStack is sending the data to your script in JSON format, and then your script does the needful, connects to I'll demo Proxmox, but can be anything you want. I wanted actually to prepare for today's Solaris zone, so I didn't have enough time, so maybe it's for next time. And an example of such workflow would be, first you add the Proxmox extension. Now 421 comes built in with it. Then you register the extension with a cluster, a CloudStack cluster. Then you add a host that is a Proxmox server somewhere to that cluster, and then you register a template, for example. We need to work with templates or an ISO. Then the user can trigger a VM deployment. Once the user has triggered the VM deployment on that particular cluster with the template that you've registered, then what happens is CloudStack executes the proxmox.sh script in the path I mentioned earlier. The script connects using the Proxmox API to Proxmox and instantiates the VM. Not only does it do that, but also does it with the right sized disk on the right network with the right VLAN and so on. The extension, although it's in early stage of development, so to say, in that it has just been shipped with CloudStack, can do actually a pretty good job. I was impressed with it because it produced actually working results and set up all the right VLANs and everything, which out of the box is pretty cool. And I understand in the next version, you'll also be able to access the console of the Proxmox VM from CloudStack, which I understand does not work now. We'll try in the demo, but I think it doesn't work in this current version. But in the 4.22, I think it will be even more polished. So in addition to the fact you can execute whatever crosses your mind and orchestrate a lot of things. And by the way, not necessarily VM. You could be deploying IoT things somewhere. CloudStack will show them as an instance, but you'll know that they are something else maybe. Maybe it's a slice in a virtual Juniper SRX appliance, or can be anything. You'll see it in CloudStack as an instance, but it can be anything. So, and then you can add your actions. For Proxmox, we have added a snapshot, list snapshots, backup, this kind of features that are more of interest to the end users, but you can really create anything you want. So you have incredible flexibility with these frameworks. This is a workflow for the custom actions. You add a custom action, then the user triggers the action, and then it gets passed on to your extension, which is assumed knows how to handle that. And then the extension does, the script does the rest that it's doing. Okay, so the orchestrator extension can deal with any external hypervisor. So right now, CloudStack supports, these are our three kind of formally supported hypervisors that actually work well and are used in production. And the external, this orchestrator extension solves the problem of, hey, what if I want to deploy anything else? So that kind of sorts you out. And the more we polish the feature, the more we add to it, the better this external hypervisor will be supported, bringing it in time, why not on par with the other core, let's say, hypervisors. So, as I said, right now, today, if you install 4.21, you have Hyper-V and Proxmox out of the box. If you want to study how it's implemented, you have the path there in the user share CloudStack management extensions. For Proxmox, incredibly, it's just, I don't know, and I'm not even sure it's 100 lines of bash script. It does a lot of stuff just with that. My colleagues did a good job, and also the Proxmox API is quite good. If you want to register your own extension, it is not difficult. You just go into the extensions link in the infrastructure menu, and you click add, and you're able to add here several things from the name, description, path, the relative path to the extension, and then the type. Right now, we only support orchestrator. And also, you have the option to, there's a checkbox there, requires prepare instance. This allows you to define extra steps that you may want to take before you have, you're going to deploy the actual VM. Maybe you want to open up some firewall port somewhere, or I don't know, random example. That could be addressed at this kind of step. Then you have the option of sending your script predefined configuration details in the format of keys and values. You can also add this at other points when you're using the extensions framework, but suffice to say you can define a few default ones here, which can be handy. Okay, and then you'll have to register your extension with the resource. Again, here you have the option of using again this key and value details. So additional resources, they can be host, template, or service offering. So you have the option of defining service offerings, such as compute offerings, where you define CPU, memory, and so on, that are targeted towards your orchestration extension. In order to trigger an action, the end user doesn't need to do anything special. They just have to choose the right, in this example, template from the list or ISO from the list, and then CloudStack will know that it needs to use the extension for that particular orchestrator. And in this case, I think it's gonna send this request to the Proxmox installation to deploy the VM. And it's a regular, normal, step-by-step instance creation that you may be used to if you've used CloudStack already. If you want to add custom actions, obviously you'll have to build your script or program in such a way that it can interpret the stuff that you'll be defining in the UI. So you have the option of adding custom actions in the UI. You give it a name, description, and then you start defining parameters and other things that the script might expect to perform that particular custom action. Needless to say, in terms of not necessarily complexity, but difficulty, this is one notch above creating the initial instance, because now you have to interrogate the state of the instance. Is it still running? Can you address it? And then run the custom action. But it's still just all relatively simple. And running the action is quite simple. There will be a new button there, run action, for the in the instance menu, so near other buttons that you may be familiar with, such as regular lifecycle ones and others. All right, so that's pretty much what I can say about this. And I wanted to say it at the start, but I kind of forgot. The slides are actually from my colleagues who have already presented this at the user group in India recently. And for the demo, they've included this this funny thing, and I decided to keep it because you always need a bit of, how can I say, a religion on your side. So, okay, first of all, let me move let me exit this and move my browser around. Okay. Okay, cool. So, first of all, this stuff is documented. This is the upstream documentation, and in order to get this demo going, all I did was to follow this. I didn't do anything outside of this. So, I have to say it was relatively easy, or maybe I just got lucky, but it kind of worked out of the box. So it's important to read the documentation. If you search CloudStack extensions framework, I'm sure this will be one of the first results, and it tells you exactly what to do to integrate Proxmox, which is what I'm going to demo now. And okay, so that's the documentation. What's happening here on the Proxmox side? This is a very standard installation. I installed it, and I don't think I've changed anything to it, so it works out of the box. The one thing I did is I registered this template called Maquilina. Do you guys see? Should I make this bigger? All right. So I've registered the template because I need to instantiate a VM from something. My colleagues used an ISO in the other demo that I was mentioning, but I think this is better because I get to showcase a bit more functionality with this particular template. So let's have a quick look at so this is CloudStack 421. I installed it yesterday or the day before, and we have this menu here, Hyper-V and Proxmox, and stuff that I've already shown in the slides. Not much to it. The name and description, and critically, the path is very important. Let me make this bigger. It's the path to proxmox.sh, which is a bash script on the CloudStack management server. All right, so I have my typical CloudStack installation here with KVM. This is running nested on my laptop, and Proxmox also running nested on my laptop. And let's try to, actually, let me show you the template that I've registered here. Storage images. Okay, so we have Machinina Prox, which I've registered. And when I've registered it, you can see here the format, the hypervisor are external, and critically, one of the key things that I've added, let me see if it shows up here somewhere. Sounds, settings, yeah, this is it. So there were two new things that I've seen when trying to register this template. That's the template type and the template ID. The template type can be either template or ISO, if you choose to boot the instance from an ISO, and then the template ID. And the template ID that I've input here is the template ID from Proxmox. It's number 100. So let's go back here. If I were to register a template again, the URL, which most of us probably use to register templates, this does not matter anymore. So you can write whatever here. Importantly, you need to associate this template with the hypervisor that is external. And then to complete, once you do that, let me see. All I'm doing is also covered in the documentation, by the way. You choose the extension that you want to add the template for, in this case Proxmox. Then you choose your OS type, I don't know, something, whatever your OS is. Ideally something I can do vert.io, because that gives you the maximum performance. Tag, and so on. So after you do that, I'm not sure whether it's at this point. Oh, external details. That's what I was talking about. Here you define your template ID and template type to tell Proxmox what kind of template this is, template or ISO. All right, so I've registered it. And I've also marked this template as password enabled because I expect it to be correctly placed onto the right network that the virtual router on the KVM, CloudStack KVM side is running on. So just so you can see, I'm not making things up. So I have my system VMs running here, and I have a virtual router running for network NAT1. And this is running in VLAN. Which VLAN is that? 142, and the other one, I think that's all I'm going to get from that. Not one, VLAN 142, yeah. And now let's try to deploy the VM. So I'm not doing anything special here. I'm just deploying from template. And instead of operating system, I choose other because that's how I register this little template as. And then I just click on the template. CloudStack will know that this is a template for an entry for Proxmox. I choose my compute offering, choose my network, the one with the virtual router. I also have an L2 network here, and that will also work, but CloudStack will complain that there are no user data services running there, i.e. no passwords to be served by anything, so it will fail. So let's try to create this one. So CloudStack European User Group 1. And let's start the, maybe let's give it some advanced stuff. I'm trying to manual user data. Let's try that as well. Let's do some easy stuff. So, okay. Just running, I'm going to write something in a text file. Okay, let's hope that will work. And let's launch the instance. And the instance is getting started. And if we watch the Proxmox tab here, there you go. We have instance I216. It's currently in state stopped because it's getting bootstrapped now. And it's already getting started. So now we have even a console, and the password for this will be given to us by CloudStack. So that's the password. I don't even actually see the password from here, but we'll use a trick to input it. Oh, what did I do? Sorry. Wrong focus. All right. 3 seconds must have passed already. All right, and we are logged in. So we are logged in. If we check the routing table, we can see that usual route to our virtual router. Then we have ET0 with an IP address from CloudStack. It's IP174. It's IP174 here, and if we do ping 10.1.1.1, which is our virtual router, too many ones. Yeah, it would have been weird if that worked. Okay, we can ping the virtual router, and let's see if we have that file I created. And we do. So we have hello CSEUG. This is the user data that I sent it. I said just echo hello into this file. So we've now deployed the CloudStack instance on Proxmox. If it has been created in the right network, if we look here at the hardware, you can see the network device is Vertio VMBR0 tag 142, which is the VLAN allocated by CloudStack. And as you've seen, we could log in with the password that CloudStack generated for it. The user data script that I passed it was also successfully executed. And importantly, this is now a CloudStack instance. So you can start doing stuff like going to the network and then do interesting stuff like port forwarding, load balancing, VPN, and all sorts of stuff. And except we'll be using that Proxmox VM for. So I think this is kind of the CloudStack UI side of things. Now, if we are to look inside, let me find my mouse cursor again. All right, so if we are to look inside the CloudStack management server, let's go check out those scripts in there. User share, CloudStack management extensions, CD US layout, Proxmox. Okay, so this is this is the script that does all of that. And of course, we try to parse a lot of JSON from Bash, and it's always fun, but by the powers of JQ, it's not so complicated. And if we look at how big this script is, 418 lines, which is actually pretty impressive considering the functionality that we get out of it. And it's all done with Bash. I mean, even I could understand it. So that says a lot. Now, if we were to hijack this script, this extension, which I did yesterday because I wanted to see what on earth is actually going on when CloudStack executes this. So I've just replaced it with a script of my own that basically does this. It just prints the environment, all the environment variables, and then prints all the parameters that are sent to the script to a log. And then I've saved the log to show you guys. I didn't want to waste time now. And this is the kind of output that we get. So the environments, all the Java stuff, all the parameters, and then critically we have the status, the action. This bit here, I'm not sure you can see anything in the back. Let me see if I can make it bigger. Come on. So we have the command here, not necessarily for what I've just done. This is older log from yesterday. The command that gets executed from CloudStack point of view just checks the status. Then the payload with information that the extension needs. And then at the end we have this 1800, which is, I think it's the timeout that this operation is to complete within. And if we look, of course we have more this kind of commands, and I saved one of these JSON files, JSON payload. Actually, let me put it through JQ. And then again through less. Or actually, will it be readable? Maybe. OK. So this is JSON, and this is what CloudStack sends to the extension. The ID of the instance, the name, the state, the type, CPU, the megahertz, minimum and maximum RAM, the architecture. So it sends pretty extensive information to the script, including going down here, the VLAN, the MAC address, the IP address. So if your script is good enough, it will just pick this JSON up and then parse it accordingly to retrieve the information that it needs. The name it needs to set, on which network to deploy it, how much CPU it should allocate, how much RAM it should allocate to it, and so on and so forth. So it's pretty extensive information. And at the bottom here, I know from the back you probably don't see, also a bit of information specific to Proxmox, like the bridge it needs to be connected into, and so on and so forth. And you can capture this by yourself, just with a silly little script like that, and then see what from here you can use, and then write your own extension. So I think I don't have much else to add at this point. Any questions, guys?
Is there a community interest towards specific extensions?
So Proxmox has been on the list for a long time. So this should appease some of those. But now anybody who has particular interests, such my own interest was to orchestrate Solaris zones, or rather OmniOS zones, with this, and it's entirely possible. So it's something that I want to do. FreeBSD jails, FreeBSD Beehive VMs, anything really. Just write a script for it. Connect on SSH, run a few custom commands, take the information you need from the JSON payload, apply it on the other side, and that's it. I mean, it's extremely powerful.
More questions?
Yeah, you just gave an example with the virtual router in use, but it doesn't mean you still run those virtual routers on KVM or something.
Yes,
Right?
the virtual router, the system VMs, they continue to run on KVM, which is what my initial installation was.
Yeah. But is that something you think the community works towards to have that?
So in the future, if we'll build more types instead of orchestrator, so if we're going to address also network and storage and so on, there is a good reason we might not need to run a virtual router in a core hypervisor, let's call them, and you can maybe run, you can maybe use the extensions to deploy a pfSense somewhere else. And by the way, these extensions could well be used to deploy this kind of appliances. Just pfSenses, you send some configuration to them via the user data or something like that. You can already kind of do that with CloudStack today, very easily. Actually, we have the VNF framework as well, but this allows you to deploy them elsewhere.
Cool. Any more questions for Lucian?
If there are no more questions, I want to add one more thing. Apologies. If you guys are interested in playing with CloudStack on Ampere hardware, we have a public demo, and it's available. Hopefully that QR code is readable. If not, just search CloudStack public demo or ShapeBlue CloudStack public demo. And yeah, that will give you access to a public demo of CloudStack where you can log in as a user, not as an admin, sadly, but as a user. And you have the option to deploy x86 VMs as well as ARM64, and they will get started on Ampere hardware.
Fantastic, thank you. Anything more for Lucian? Any more questions?
Okay,
Thank you, Lucian.
no worries.